Estimating population means with sigma known, its population standard deviation will be known. I'm not going to read this to you, just going to highlight some things. Anytime you see point estimate, that's pretty much going to refer to the mean, sample mean, X bar, point estimate, unbiased and unbiased estimator. And it says it right there. So when you see a question like this, it just means find the mean. When it's asking for to obtain the point estimate, find the sample mean. And as always, when you find the sample mean, you add up all the values, and which I'm not going to do it that way. Add up all the data values and divide by 12, because there's 12 here. I'm just going to stat, edit, and just type them in this way. I'm using my keypad in case you wonder what I'm doing. Just going left to right, trying to be fast about it, because I don't want to spend a lot of time on this. Just typing them in. Hopefully I type them in correctly. And then second quit, stat, calc, enter, enter. And you get 67.7 because that's the X bar. And we're going to be dealing with confidence intervals. You probably have seen those somewhere on the news, opinion polls, whatever it may be. What these are, this is the interval that we're confident. For example, like 95% confident that the population mean will be between the two values that we're going to find, the lower bound and upper bound of the confidence interval. And they do have a margin of error. You've probably seen on TV, plus or minus some number. You'll take like the X bar, which is the sample mean. And this is an estimate for the population mean. That's what this is. We're just doing an interval, so you do like plus the margin of error, and then you'll do X bar minus the margin of error, and we'll call E the margin of error. So for examples like 47% are in favor, plus or minus 3%, you do plus 3, 47% minus 3, which will give you a confidence interval of 50%, or 44 to 50%. For example, let's say we're 99 or 95% confident that the population mean is between 44 and 50. So it gives us a pretty good range of values to consider. Central limit theorem will be used mainly in this class if the sample size is greater than or equal to 30, or if the population distribution is approximately normal. The main thing is the sigma is known. If sigma is known, if the population standard deviation is known, that's a z. Just keep that in mind, that's a z in this class. And so if you read this, you're going to have some like a 95% confidence interval. What that means is in between these two z values, the negative z and the positive z, that area will be 95%. And we'll be looking for the z alpha over 2. So that's this representation. Now what this is, we're using this formula, alpha equals 1 minus c. So if you have like a 95% confidence interval, that means c is going to be 0.95. Alpha is going to be 1 minus, I'm not sure what that is, 1 minus 0.95, which is 0.05. And then we'll need alpha over 2, which is actually the area to the right of the z-score. So alpha over 2 is 0.05 over 2, which is 0.025. And if you don't believe me, you can always check it through the calculator. 1 minus 0.95, I'll start it over so we can see it. And divide that by 2. So we'll be looking for 0.025 somehow, some way, either by table or by calculator. I'm doing everything by calculator today in this video. Anyway, if you want me to show you by hand how to do these things, how to do the computations, which means I'll do it by table and by formulas, just let me know. So this is the area to the right we'll be considering. And so when we do these, we'll be using the inverse norm key, which it does give us the area to the left, right over here. I am doing. Yes, I do. I don't want to keep doing that. Hey, it's a video. That's what happens. So we get area to the left. And that's pretty much all we'll need for these questions. If I want to do more, I do mu and then sigma. But not for these when I'm dealing with the z-scores only. So I want to find the critical value that corresponds to a 94% confidence level. So what I want to do is, that 94% means that in between these two z-scores, I have 0.94. What that means is, in the two tails together, I have 0.06. In one of the tails, I divide that by 2 and I get 0.03. So I'm looking at 0.03 there or there. Since inverse norm is what I'm going to use, is area to the left, I'm going to use 0.03. So second vars 3 is inverse norm. This is a TI-84, 0.03, and I just hit enter. And since this is area to the right, I use the positive value, so the answer is 1.88. Let's do this one. Same reasoning. 90% between these two z-scores is 0.90, and if you subtract 1 from 0.90, you get 0.1, and if you divide that by 2, which I probably shouldn't put equals there to be mathematically correct. If you take the 0.10 and divide by 2, you get 0.05. So we're looking at that area, 0.05. I need the area to the left because the inverse norm is the area to the left. So 3.05. Just hit enter. And I use the positive value, so it's 1.645. Something I want to show you on the table, which I am going to use the table. I'm always going to look at the table. This is the second part of the table of the standard normal distribution for this textbook, which is the Hawks textbook. If you take a look down here, you have a table of critical values of z. What we just did, we have a 9% confidence level. And this is our confidence level, 0.90. That's our alpha, but this is the z, which is 1.645. So I didn't actually have to use the calculator. This table is actually way faster. A lot of tables don't have this. This one happens to have this. So 1.645. If you want to know how to do it with a regular table, you go in here and search for 0.9, the closest value you can find. And it looks like, where's it at? 0.9. Well, I'm wrong. See, it's actually way easier to do this because that 0.9 confidence interval is in this range. If you look what I have here, if you add that onto it, it makes it 0.95. So in the table, you actually have to look for 0.95, 0.995, I should say. No, 0.95. I was right the first time. What did I doubt myself? So 0.95 is actually right in the middle of these two values. It's equal distance. So I do an average of those two. So I have 1.6, and then I'm going to move up here, and the halfway between those two is 0.045. So 1.645 is where that comes from. The moral of the story is, if you have this is easy, extremely easy, or this is easy. Using the table can be way more difficult because there's more to consider. It's not the 0.9 you look at the middle, it's everything to the left of this is the value, because that's what the table values give you. So, in other words, use your calculator or use this chart. So let's continue on with this section. Now the margin of error, the formula is given by this. We will use this if we need to. It is included in the confidence interval, which I've already mentioned before. I've already given you an example. However, I am not about to do this by hand unless you let me know. send me an email, post a message or a comment on the video in YouTube, and I'd be more than happy to show you by hand. But I'm going to show you what this calculator can actually do for you. We're going to construct a 90% confidence interval. So I'm going to go to Stat, Test, and I have to read this first. When you read this, we do know sigma, and it does have a sample size greater than 30. So this is a z. So this is a z interval. So I'm going to click on 7 for the z interval, and you'll see that we have all kinds of things that we need. So I'm going to hit enter for stats. Now yours may not have all this information, but it probably does. It probably does. So let's see if we can find out all of these. Sigma is given to be 29. Enter. X bar, which is a sample mean, is 526. Enter. Sample size of 106. Enter. And the confidence interval, the confidence level, is 90%, which is 0.90. Enter, and just hit enter again, and you'll see the answer: 521.4, 530.6. There is no easier way. Maybe some other type of technology, but I'm using TI-84. Let's do this one. Well, I gotta look at the problem first. Sigma is known. Sample is greater than or equal to 30. This is a z. So let's go back to stat, test, z interval is 7. I want to keep it on stats. Sigma is given to be 3.9. X bar, I have to look. The sample has a mean weight of 20. Well, this is our X bar. That says equals X bar. The sample size is 131. And their confidence level is 0.95. Enter, enter. And we see 19.3 to 20.7. So this is our answer, C. Let me see if that's it. Nope. Continue on. Now if you take the margin of error formula, which the E, you take this formula and you solve for N algebraically, this is what results. Now, the hardest part is finding the Z alpha over 2. Everything, the E and the sigma will be given to you. So you gotta find the Z alpha over 2. So let's do some examples. 90% confident. The first thing I always do, I go to the table, see if I can find 0.90, and I have it, so I'm going to use Z alpha over 2 is 1.645. Then I use my formula. So 1.645 times sigma. Well, the variance is 324, so I can actually, and that's sigma squared is the variance. So sigma would be the square root of 324, which I do believe is 18. So let's just check to make sure. What do you know? So I want to use 18 divided by the margin of error. So it says will not differ from the population mean by more than 3.8. That's our E. And then squared. So now what I'm going to do is I'm going to take out my calculator and just type that in just the way it is. 1.645 times 18 divided by 3.8, close it, squared, enter. Always round up, no matter what. You always round up. So you get N is equal to 61. So the answer is C. Looks like I have one more example. That's your sigma, which is 575. Samples, we need the N. Confidence interval is 95%. Margin of error, you're told, is 131. So let's take out our calculator. Well, first off, let's throw in all the numbers. I need what I need before I can do this. I need my z alpha over 2. Once again, I go straight to my table because it's 0.95, which is one of those nice values. So I use 1.96. See that? 95%, 95%, 1.96. So I'm going to use 1.96 times my sigma, which is 5. I can't say it. I can't write a 7. 575 divided by E, which is 131 squared. 1.96 times 575 divided by 131 squared. I always round up. We get 75. And we'll check just to make sure that's the last example. Yep, and we're finished.